Today we're covering lesson 97, and it's more on volumes of solids. It's just a completely different method of using it. If you look on page 498, it tells you the basic integral for volume is the integral from a to b of pi r squared dx. And so pi r squared is just the area of a disk. Well, they're not always going to be circular disks. So at the bottom of page 498, it says the base of a solid is the region R, which is bounded by, just write these down, y equals 1/2 x, and y equals negative 1/2 x plus 4, and the y-axis. Every vertical cross-section of the solid parallel to the y-axis is a rectangle with a height of 5. I'll make a note of that to myself. Find the volume of the solid. So I have this picture right here for us to look at, and you'll notice that this is the x-axis, so it's sideways, but so this is the x and this would be the y right here. So this rectangle right here is a cross-section where it said that each cross-section was a rectangle with height 5. So in other words, this height right here is always 5. What we're going to do is we're going to start at 0 back here and add up all these rectangular cross sections that would come in here. So we need to find out where these intersect. You can see from the graph where they intersect, but if you don't have a graph, you're going to need to know how to do that. So you just take these two equations and set them equal to each other. So this would be x is equal to 4. So we're integrating from here to here. All right, so let's set this up. The integral from 0 to 4. We're going to integrate the area. So the area is the height times the length, or base times height, whichever way you want. But in this case, the height is always 5. So I'm just going to go ahead and put it here. And then this length right here will be this y value minus this y value. So this equation is the equation that has the negative slope. So that's going to be minus 1/2 x plus 4, and then minus this one. And then, don't forget your dx, please. All right, so we can pull the 5 out. Oops, that's 1/2 x, sorry. We can pull the 5 out. And then minus 1/2 x and minus 1/2 x would be minus x plus 4 dx. So we integrate that, and that will give us the area, or excuse me, the volume of this solid right here. So 5 times would be minus x squared over 2 plus 4x, evaluated from 0 to 4, which is 5 times minus 16 over 2 plus 4 times 4, and minus, plug in 0, you're just going to get 0. So that's 5 times minus 8 plus 16. So that would be 5 times 8, which is 40. All right, so that's when you have a constant height. Okay, remember they always give us one that's a little bit different than the normal ones to begin with. So let's go ahead and look at the next example. Bottom of page 499. It says the base of a solid is the region enclosed by a circle with radius of 2 units centered at the origin. Okay, well, when I read that, I know that that's the equation right there. All vertical cross sections parallel to the y-axis are squares. Find the volume of the solid. Okay, so let's look at this picture. Oops. Oh, I got it twice. Okay, it's going to have to stay there. All right. Notice that this is the y-axis. So the length of one of these sides of this square, if this is y, this would also be y because it's a circle, remember? So the length of the square, length of the side of the square would be 2y, right? So then the area of one of these squares would be the side squared. So that's the area of one of the squares. Now, we're going to integrate this from, we're going to take this all the way from, this is on the x-axis, from here to here. Okay, so we don't want y's in our equation, we want x's in our equation, because remember this would be, the radius of the circle was 2, so this would be -2 here, and this would be +2 here. So we go back up here to this equation, and we need to solve this for y. So y squared would be equal to 4 minus x squared, or y would be equal to the square root of that. So when we set up the integral, remember we're integrating from here to here. And the area of one of the squares is this, so I need to change this in terms of x. So this would be 2 times the square root of 4 minus x squared, which then gives us 4 times 4 minus x squared, and then times the dx. Now one thing that we can do is, instead of taking the integral from -2 to +2, they're symmetrical, so we could actually say 2 times the integral from 0 to 2 of 4 times 4 minus x squared dx. And we can pull the 4 out because it's a constant. Eight times the integral 0 to 2 of 4 minus x squared dx. So then that will be 8 times 4x minus x cubed over 3 evaluated from 0 to 2. So then that's going to be 8 times, that'll be 8 minus 8/3, and then if you plug in 0, it would all just be 0. So that's 8 times, get a common denominator, 24 minus 8. So that's 8 times 16/3, which is 128 over 3. All right, so that's not too bad. We have one example left. Down at the bottom of page 500, 97.3 says, a solid has a circular base of radius 2. Okay, well, we've got that circular base of radius 2 again, so that's x squared plus y squared is equal to 4. Vertical cross sections perpendicular to the base are equilateral triangles. Find the volume of the solid. All right, so here's the picture for this one. So this is an equilateral triangle, okay? And again, this way, if this is the x-axis, this would be -2, +2. So in order to find the area of one of these triangles, remember it's an equilateral triangle, so we know it's 60, 60, 60. So if we draw the height, now we have a 30, 60, 90 triangle. And let's see, the triangle here, this would be the length of the base would be, this would be 2y. The whole thing, so one of these would be y. And then using 30, 60, 90 relationships, this would be square root of 3y. All right, so then the area of one of the triangles would be 1/2 the base, which is 2y, times the height, which is square root of 3y. Okay, so that simplifies to be, the 2's cancel, and we end up with square root of 3 y squared. But here again, we're going to integrate from x equals -2 to +2. So we need this to be in terms of x. So remember, y was equal to the square root of 4 minus x squared. So we just put that in right here. Square root of 3 times 4 minus x squared squared. So that's the area of one triangle in terms of x. So we put that in here. Square root of 3, 4 minus x squared squared dx. Oops, that was square root of that. So this actually, after I square that, this goes away. All right. Now, again, we can simplify matters by taking 2 times the integral from 0 to 2 of the square root of 3 times 4 minus x squared. And this is also a constant, so let's pull it out. And we can integrate this and get 4x minus x cubed over 3 evaluated from 0 to 2. So that will be 2 square root of 3 times 8 minus 8/3. What's the same thing that we just got a minute ago? So this was 2 square root of 3 times 16 over 3. So that was going to be 32 square root of 3 over 3. All right, so just find the area of one of the cross sections, whatever that is, find the area of one of them, and plug them into an integral so that you're actually summing up all, like this one, all of the triangles that would go here.